Hey, everybody, this is Larry. It is January 23rd of 2023. Hit the like button, to subscribe button, join me in Discord. Let me know what you think about today's poem. So this is not the bonus question yet, or this is not the daily question. Oops. Because it's a little bit before the time release. I think there's like half an hour before that. So I'm going to do a bonus question first. And yeah, let's get one. Go, go, go. And today's bonus question, or Larry's extra question, is 988, smallest string starting from leaf. Again, not a premium question, so definitely feel free to do with me. Okay, so now you're given a root of a binary tree. Each node has 0 to 25, representing the letter A to Z, which I guess they could just use A to Z. What's going on? Return the lexicographically small string that starts at the leaf and ends at the root. As a reminder, any shortest prefix of a string is lexicographically smaller. Any shorter prefix of a string. AP, okay, yeah, of course. Okay. Okay, so there's D. Is this a complete tree? I guess it doesn't have to be, right? Let's think about how to best do it. I mean, wow, that's really specific. I mean, you can definitely do a linear thing. Like if you, my first thought process is trying to see if I could do a depth first search, and of course, maybe you can, but then you have to do comparisons, and I don't know that. Like it can probably degenerate into something like n squared, but I could be wrong just by like the number of comparisons for the lexicographically smallest. But maybe it doesn't come into play, so we'll keep that in the back pocket and not do it yet. How would I think about it? So the weird thing about this particular one is not a weird thing, but and I think we can also maybe do a bucket sort type thing, in that we basically keep track of the parent, which is the next node in the string, right? Or next character in the string, and therefore also the next node in that tree, and then kind of not quite a bucket sort, but like just walk the smallest thing, right? And at worst, that's going to be 26 times n if you have one like this or something like that, and they're all z's or something. And I think that should be good. Yeah, okay, let's do it that way. It's a little bit weird, a little bit annoying, but maybe it is fine. It's I'm trying to think whether there's even a slicker way. Because basically what I'm kind of doing now that I think about it is kind of like doing it like a try almost, right? And if we're doing it like a try, can we do it in a smarter way, right? Other than, everyone. Because basically what I was thinking of is just like almost like every start at the leaf node and then kind of go up and then up and up, up and up. But that can actually degenerate as well. So maybe that's not actually good enough. Can we do something with respect to it's also possible that I'm overthinking it, to be honest, but I think if we have a way to just ask a query of like, okay, is there leaf with A, and then is there second thing with B, and so forth, I think that should be okay. But as long as we're able to do it all at the same time, but that's could degenerate. Wow, this is am I overcomplicated thing? And at the thinking about it, because I think that a lot of my cases, and this may be, I don't know. I hope that this isn't one of those problems where the input is just not strict enough, right? Because then that just means that I'm wasting my time. But there definitely can be a way to kind of degenerate both of those things in a square or n square. Problem is that if all of them are the same, then you kind of keep on just going up, right? Like basically, if you have the entire tree is the same letter, for example, then you just keep on going up. And then if you have a complete tree of say n over 2 nodes at the bottom, then that's going to be n over 2 times. Maybe that is not well. In that case, it'll be log n, but then the depth of the tree will be log n, so then it'll be n log n. But n log n, let's see, so the n of them, and then n log n depths, maybe, but then what if you have one of them that's, it is definitely very awkward. Try to think whether there's a way to do it backwards from the root. I don't know that there is though. That's the thing. And of course the random case is going to be fast, but it's about the worst case. And we want to be able to process stuff without processing all of them. I mean, maybe we can merge them if they're the same node, but I feel like that's hard to bookkeep too, right? This is only a medium? Am I missing something obvious? I mean, we do want it to be greedy in some way, but just not sure how. Is that case n log n, not n square? Maybe. Well, all right, let's try it, and then maybe this is just one of those YOLO problems where maybe I did the math silly. All right, let's go. Let's go traverse. Right, yeah, it's a left-right tree. Okay. Something like that, and then just and then maybe something like, okay, if node dot left is none, oh, I have to do this actually. It's none, and node dot right is none, and this is a leaf, and then we just set it into the I don't know, just call it start. Something like this, maybe. Right, and then we traverse root none, something like that. Let's just let's just see if this runs. Okay, that's good. Maybe, I mean, it's expected. And then now we want excuse me, yikes. I did heavy squats today, so I'm just like really tired. It really burns out my system. Maybe it's time to take a break from that. But yeah, okay, so then now we just basically for how do we want to do it? we actually want this to be maybe something like this, and then someone like this. Okay, so then now we can reconstruct answers equal to for maybe something like while true. We'll maybe change the condition later for, and maybe this is yeah, start is a terrible name. Maybe current. I don't know if current is better, but and then maybe like next level is equal to collection default dot list. Okay, and then for I in range of 26, right, something like that. If I in current, then we break answer dot append char of I plus this to get back to thing, and then we break, and then what are we doing, right? We basically go I guess I can do something like this, maybe even. Then now for current sub I, right, for node in current sub I, no, we want to get the parent, get the value, and then next level we want to append parent.node, right, or parent sub node, basically the same thing that we had there, right? And then afterwards current is equal to the next level, and then we do it again. Okay, and then maybe this is found is equal to false, and then found is equal to true. If found, or if not found, then what do we do if it's not found? Also, we do actually want this to happen, to point at none, so then we can maybe do a thing on it. If parent node is none, then we return put this in first, because then we can because that means that we hit the root after using this character. Okay, if it's not found, then no, I mean, I think this is fine, because this should go until it hits a root eventually, so it should be good, even though this looks really awkward. Maybe I'm wrong and this is infinite looping. All right, I don't know if this times out or not, so we'll see, but apparently it's fast enough. Maybe I did the analysis wrong, because I was thinking about this pretty early on, but let's see. I mean, I guess the worst case is that there are n over 2 leaves, but then the depth is over log n. Is there if the depth is n over 2, then I guess you only have 2 leaves. Is that right? No, I guess it doesn't have to be right. But maybe there's some like n log n bound type thing. I don't know. I'm not really good at proving this one, so but I think maybe that's right, and that the worst case is that you have n over 2 leaves, and they're all the same character. But then in that case, the depth will be log n, and then it's n log n. And I did the naive thing of thinking that was n squared. It's kind of tricky though. I don't know that I explained this one because I wasn't sure about this one. Basically, the idea is just keep track of all the node value or all the leaf values by using the traversal. This is linear time, linear space, and then almost kind of like a breadth first search or something like that, where you greedily go, okay, is there an A in the current level? And the current level is just the leaf, right? So it's not the same level as the depth, but it's just the same level from the leaf that the node is from, right? And then if there's an A, then we do this stuff, and then we add the A, and then we go to the next level for each of those nodes. We go up one to go to the parent. If one of them is the root, then that means that we're done, because, well, we want the shortest prefix anyway, so that means that we're done. If not, then yeah, then we repeat this again then we repeat this again with the next level being the set to the new level, and then we see if there's an A. So basically, in a greedy way, you go, okay, is there A? There is an A. Okay, is there an AA? No. Is there AB? Is there an AC? Dot dot dot. And then in that way, you do 26 times n at most, or 26 times the depth of the tree, which I guess could be n, could be log n, but yeah, apparently it is fast enough though. I don't know. Is there a better solution on this one? This is not a really useful discussion. I'm curious. Brute force. Is the brute force fast enough? This is not n all of n though, but I mean, I guess I could have done it this way. I wasn't sure, but it's still not all of n because of this comparison. This comparison is not constant. But I guess I wasn't sure. I guess that would have been fast enough, just simple pre-order. Okay, I mean, maybe I made this problem more complicated. I can't even say the word. Maybe I made this problem more complicated than it is. So let me know what you think. Stay good, stay healthy to good mental health. I'll do the daily problem, well, when it comes up next. And I'll see you in a little bit. Bye-bye.